Okay, so in this video we're looking at some scientific notation problems. I've got 5 questions total. What I have got here today, I've got a calculator up just so you can see how to sort of type in the scientific notation, because a lot of people get a bit confused about it, but it's much more straightforward than what you think. So this app here is called Desmos. You can find it online on your computer as well, but there is also an app you can download and it's really good. I think this is one of the best sort of scientific calculator apps. It's certainly a lot better than the standard phone calculator that comes with it for free. But let's just jump straight into this question here. So light travels at 1.85 miles per second. So I'm going to highlight that because that's going to definitely be an important bit of information for me to use. How far would it travel in an hour? So first thing, that first little highlighted part, that means in 1 second we're travelling at 1.85 times 10 to the 5. Our goal is to eventually get to 1 hour. And the easiest way to do this is to just work your way through, work up to it. So when you think how far it will travel in 1 minute, well, 1 minute is the same as 60 seconds. And so I've got to multiply that by 60. And so I've got to do the same thing over here. I've got to multiply that big number by 60. Now look at my Desmos calculator. Way to do that. Firstly, I recommend putting your scientific notation bit in brackets when you use it, just because sometimes something weird can happen. And if you get in the habit of putting brackets around it every time, you're going to help eliminate the weirdness that can occur, because calculators can sometimes be too smart for their own good. So I'm going to put that in brackets, so 1.85. Now, on a normal calculator, there is a button that looks like this. I personally hate that button. I don't like using it. What I do instead is that I write out times 10 and then the power. So times 10, and here it's a little dot, but I just hit my little multiplication sign there, to the power of 5. Use my arrow and then I close my bracket. And so I'm going to times that by 60. And so up there on the right hand side I've got my answer. So 111 and then 5 zeros. And then to get to 1 hour, well, 1 hour, remember, is 60 minutes. So I've got to times that by 60. And therefore I've got to times it by 60 again. So I'm going to press answer. So hit enter there. So that's remembered my previous answer. So I press answer times 60. So it's going to be 666 million. And if this question then asked me to also give my answer in scientific notation, and I think the original question did, I must have just missed it off. Remember, my decimal point is here. I want it to go here. So I'm going to have 6.66 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 miles. And that is my first question done. So let's take a look at another one then. Okay, so here, in 1 gram of carbon, so I'm going to highlight 1 gram of carbon, there are 6 times 10 to the 26 atoms. How many carbon atoms? Actually, let's do a slightly different highlighter. Let's go for orange. So how many carbon atoms are there in 5 kilograms of pure carbon? So we are told in that first bit in blue that 1 gram equals 6 times 10 to the 26 atoms. The thing we don't know in that bit in orange is how many are in 5 kilograms. 5 kilograms is the same as 5,000 grams. So to get from 1 to 5,000, I've got to times that by 5,000. And therefore, I've got to do the same thing over here. And as you can see, how I'm laying this out is actually quite similar to how I teach reverse percentages, of just sort of having things on the same side they're meant to be. And this is a really good way to sort of indicate what you're meant to do with the numbers you've been given. 6 times 10 to the power of 26 times 5,000. And there, my answer is going to be 3 times 10 to the 30 atoms. And sometimes your calculator will automatically put it into scientific notation, like so. And that's that question done. Okay, next one. Bit of a long one to read here, so get my highlighter out. The population of Scotland in June was 5.09 times 10 to the 6 people. I'll highlight Scotland there. Then, the population of China in June was approximately 250 times larger than that of Scotland. Calculate, correct to 3 significant figures, the population of China. Okay, so we know that Scotland is at 5.09 times 10 to the 6. What we're trying to work out is what China is, but we are told that China is 250 times larger than Scotland. And so therefore I just got to take this number here and times it by 250. So again, putting in brackets, 5.09 times 10 to the 6. And make sure when you're up here with the power, you do press the arrow sign to go back down. You see how my little line cursor bit moves down. Make sure you are back down, otherwise you'll get errors on your calculator. And then times 250. And so first it gives me this answer here of 1.2725 times 10 to the 9. We are told we want it to 3 significant figures. So I look at my 4 significant figure. That's my first, that's my second, that's my third, that's my fourth. 2 rounds down, so that means the 7 in front stays the same. And that's my answer. Okay, question 4 then. Venus and Earth are 2 planets within our solar system. The volume of Venus is approximately 9.3 times 10 to the 11. So Venus, that is Venus's approximate volume. And then we are told that this is 85% of the volume of Earth. And we are being asked to calculate the volume of Earth. Okay, so first writing out what I know. So Venus equals 9.3 times 10 to the 11. And the thing that we're trying to figure out is what Earth's volume is. We are told that Venus is 85% of the volume of Earth. And Earth would be 100% of Earth, because Earth is that sort of final, Earth is all Earth. We know that for sure. And what we've got here, we've actually got a reverse percentage that has been mixed into a scientific notation problem. So same as always, we want to go down to 1%. So to get from 85 to 1%, I divide by 85, and therefore on this side, I also got to divide by 85. So putting that in brackets, I've got 9.3 times 10 to 11 divided by 85. And this is what it comes out with. I'm just going to write the whole thing for the time being. You never really want to round midway through a question. And then to get from 1% to 100%, I times that by 100. And so therefore I've got to times this by 100. Ooh, got a bit squished there. So then I'll do answer times by 100. And it is a really good thing becoming familiar with that answer button, because it saves you so much effort having to retype things. And here I am just going to round it to those 3 decimal places, because that 1 will round down. So I've got 1.094 times 10 to the 12. Okay, one last question then. So a pollen sample weighs 12 grams and contains 1.5 times 10 to the 9 pollen grains. Calculate the weight of 1, and now in this exam they did have that 1 embolded? That 1 in bold, just to really emphasize that is definitely a key feature you need to use. So we want to know the weight of 1 pollen grain and give your answer in scientific notation. So first, writing out what I know, so that first top part, 12 grams equals 1.5 times 10 to the 9 pollen grains. So this is where some people make a mistake. Now, a lot of people will put a 1 there just because they get in the habit of, it's always going to be on that left-hand side. But read carefully. It says weight of 1 pollen grain. So we only have 1 pollen grain. And so that means to get from here to here, I got to divide that number by itself to get to 1. And so therefore that 12, I got to divide it by that 1.5 times 10 to the 9. And so in my calculator, 12 divided by, putting it in brackets, 1.5 times 10 to the power of 9. And so the weight of 1 pollen grain is going to be 8 times 10 to the negative 9. Negative 9 grams. So that's how to tackle these sort of questions. It is just one of those, best to sort of pick out that key information and write it down and see where you're missing elements. Because that's what I've done for pretty much every single question. This is the only one where something else has to be applied. But every single one of these, by writing down what I've been told and where I am missing information, that has helped me massively with figuring out these questions. Let me know if there are any issues, and